Hey everybody, welcome back. So today we will discuss another cool new feature that Databricks has introduced. Currently in the beta version of 18.1 runtime, but soon it will be available in the upcoming runtimes of Databricks. So feature is insert into with schema evolution. So Databricks is consistently working for the schema evolution problem. So in a real data engineering pipeline, schema evolves all the time, right? And a new column introduced may lead to the pipeline failure or maybe traditionally breaks the ingestion pipelines unless the engineers manually updated the schema. But with this feature, it will automatically take care of the new columns introduced in the table. So this is the very simple syntax: insert with schema evolution into the table, and then we just have a select query from new table where we expect the schema is evolved. So let's consider a business case. So our business case is, let's imagine a manufacturing plant where our smart devices are currently being manufactured, and we have some real-time IoT sensors that send us the temperature of the plant. So let's see the scenario: factory monitoring scenario. Machines continuously send temperatures. If the temperature crosses a certain threshold, the production must stop. Initially, the system only relied on the sensor readings, but then there were some manual interventions also being requested. So operators requested manual override capability. So if somebody present on the plant on a particular shift observes that machine manufacturing needs to be stopped due to higher temperature, and manual intervention was allowed. So a new column, the flag of manual stop was added. 0 means no manual stop and 1 means manually stopped by the operator key. And this is the complete IoT pipeline. So the sensor senses the machines and then gives us the raw data. Then the bronze layer is established. Then we have the clean data in the silver, and then finally the data is given to the monitoring dashboard. So this is a very high level overview of how the factory is working currently. Then this is the schema evaluation. Initial schema only consists of three columns: device ID, event type, temperature, whereas the new schema has a manual stop flag column added. Then the problem that Databricks identified in certain cases like these was the new column that was added in after the manual override flag is inserted. We needed to either drop create the tables, and traditionally in the ingestion pipelines, it led to a lot of failures, pipeline breaks. So the Databricks solution is this: insert with schema evolution into the target table. It automatically detects the new column, updates the schema, and inserts new records. So this current solution is very useful for IoT pipelines or for even in the healthcare systems, and in all the cases where the impact is very high and we cannot just afford for an ingestion pipeline to break, right? And this solution reduces the need of alter table operations. It's available in the Databricks runtime of 18.1 beta. In our example, the threshold temperature is at 79. So if our sensor detects a temperature greater than 79, it should be stopped. The manufacturing plant should stop manufacturing that device. So now we are in our Databricks environment, and if I hover over the compute, it says 18.1. So this is the minimum requirement of this new feature that Databricks launched. So it insert into with schema evolution will only work on the 18.1 or higher runtimes. Okay, so this is our bronze table in the ingestion layer, and as discussed in our example, it has only three columns. I have also printed the schema of this equal df, and it has these three columns: device ID, event type, and temperature, as discussed in our example. Then we have this new device temperature. This is the table where the schema is involved. The operator flag is added. So this is the manual stop flag column that has been added in this new table, and we will try to print the schema as well. It will show four columns. Correct. So it has the four columns. The manual stop flag has been added. Now we will use that syntax insert into, and we will add this with. If we do not add the with schema evolution, it will fail. So let's add, try to add this without that syntax. So it fails because a column hasn't been added. But if we type with schema and we take this into and we add it here, and now it has added the 5 rows. So let's select all from this new table or from the table that we inserted the new rows in. So see, we now see the new column added into the old table, and we don't need to add any alter table command or any drop creates required. So we see how this insert into with schema evolution makes our ingestion pipeline or the ingestion flow more robust without the need of drop creating or altering any tables. But we should also consider of how to handle the nulls for the pre-existing values before the schema evolution. Finally, if you found this video helpful, please share it among fellow data and AI enthusiasts, and more videos await. So see you next time.